Welcome to another edition of Design Spark Ask the Expert. Today we're going to be talking about solar power and solar farms. And our expert today is Will White from Fluke. Hi, Will. Would you like to say hello to Design Spark?
How's it going? I'm glad to be here today. Thanks.
Great. Well, thanks for joining us, Will. Solar power it is certainly big news. There's obviously a growing domestic use, and that's probably how most people are aware of solar power. But also on a large scale, we're talking about solar farms that are feeding into national and regional grids. They're becoming much more visible as we diverse away from fossil fuel as an energy source. So could you just highlight the different elements that make up a complete solar powered system, for example?
Yeah, absolutely. We'll start at the solar modules. You have an array of solar modules. Those modules are connected to form the array, attached to some form of racking, be it racking on the roof of a building, ground-mounted racking that you see in those larger solar farms. From there, the modules typically connect into an inverter. Inverters are the electrical equipment that convert the DC electricity produced by the solar modules to AC electricity, which is what we typically use in our buildings. So that connects directly into the utility grid where excess generation is fed into the broader utility.
Right. Okay. So there are certain elements there, and I think we'll come on to a few of those because obviously Fluke have products which are heavily associated with each of those elements as well. So yeah. I'm interested about sort of like the power side of things from solar panels. So when we talk about power, from Ohm's law, it's volt time current, for example. So relatively speaking, a simple calculation. When it comes to solar panels and current ratings, for example, each panel has a voltage and a current rating in terms of power generation.
Sure.
But what about solar irradiance? What exactly is that, and how does that kind of feed into the power equation?
Yeah, absolutely. So irradiance is really simply the energy contained in the sun. So that's how we measure essentially the resource that's available to generate solar electricity. So as you mentioned, each module has a voltage and current rating. Voltage times current equals power, and that's the amount they're able to produce instantaneously at any one time. So modules, when we test modules, they're tested at a set of standard conditions. So if we have a 400-watt module, that's tested under certain irradiance conditions. It's 1,000 watts per meter squared is the standard. But we all know that the sun comes and goes. It's less intense in the morning and the afternoon. It tends to be more intense during the middle of the day. We've got clouds coming and going. So as that irradiance changes, the power of the output of the module changes. Now, for most people, power, which is an instantaneous measurement, it's how much is being produced right at this moment, is not really essential to know. We're more interested in how much energy is being produced, which is power over time. Energy is measured in watts, kilowatt, or watt hours, kilowatt hours, megawatt hours. Most people are interested in kilowatt hours because that's what we're charged for on our electric bills. So that's really the measurement that we're really concerned with. And we can get that reading on our inverters, on our monitoring platform. And in most cases, when we're connected to the utility, we'll get some information from the utility on production as well.
Great. So in terms of solar irradiance values, they're obviously important for making the power calculations. But as obviously with Fluke, you have meters that can measure most things, I would imagine.
We do.
So
yep.
What is it about irradiance? How do you actually measure for that? And do you have products that help users to do that?
We do. So Fluke has an irradiance meter. So it's a small handheld meter that people can use to see what the irradiance is at that time. We in the industry use meters like that when we're doing performance evaluation. So if we're going to go and install a system, we've got it completed and we want to test to make sure it's performing to our expectations, we will use the irradiance meter to check and see what that resource is at the time that we're measuring the performance to ensure that the performance of the system is equal to what our expectations are. Now, when you get to looking at whether, is this a good site or a good region for solar, we have software available from different sources that will do production estimates over the year.
Right.
the sun values vary throughout the year. Here, I'm in Vermont in the Northeast United States. It's a relatively cloudy region. It's probably similar to the weather that you guys experience in England. We get cloudy in the wintertime, sunny in the summertime. So our resource is much greater in the summer than it is in the winter. So what designers will do is they will plug the site address into the software, and then we'll plug in the information about the system size and characteristics, and then it will produce a annual energy production estimate. So it'll tell us how many kilowatt hours that system is going to generate. That's really important for when we're doing financial calculations, looking to see the viability of the site. We also have other tools that are available to do on-site shading analysis. Shading has a really big impact on the production of solar, so we want to make sure that we're installing systems that are in unshaded locations for the most part. So we'll use different tools. Fluke doesn't have any of those tools available, but there are, and actually most people are using software these days to calculate shading on sites. So we're using satellite imaging and LiDAR, which is a radar detection to indicate height of trees and buildings and things like that.
Yeah, that's really interesting. So a lot of the survey is already, the information is there in terms of picking those sites which are going to give you the best benefit versus investment costs, for example. So that's really useful to know. Mm-hmm. One of the other areas which I'm interested in is I've known Fluke products for a long time, obviously installation, testers, multimeters, and scopes, for example. What is it about safety testing for solar power installations? What are we looking at in terms of procedural safety tests for these?
Yeah, solar is a little different than most other electrical equipment. Usually, if you're working with a motor or something like that, you can shut the power off to that device. So it's de-energized so you can work on it safely. With solar modules, as long as there's sun out, they're energized. So there's always a safety hazard there unless you're working with them at night. What we're doing to test, we're typically doing voltage and current testing. So Fluke has many different multimeters, digital multimeters. We have clamp-on amp meters to test for current. So we're testing to see if there's voltage present. We're also testing to see if there's current flowing through the circuit. There's many parts of solar installations that are not capable of being disconnected under load. So we want to make sure that we're testing to make sure that there's no current flowing through that circuit. We also have thermal imaging cameras that we use, which is a very common diagnostic tool in solar to see if the module is working properly, to see if it's damaged. The interesting thing about solar modules, and this is kind of counterintuitive for most people, is that solar modules actually operate at a lower temperature when they're working properly. Those electrons have somewhere to go when the module is operating. So when the module is not working properly, the electrons don't have anywhere to go, so that energy or a certain portion of that energy is being released as heat. So we can see with a thermal camera if that module is hot, then there's usually an indication that it's not operating properly.
Great. So I'm glad you touched on maintenance there, because maintenance testing and fault finding, I've always wondered when I'm traveling around, I see these big solar farms, for example. If one of those panels is faulty, how do you know? So in terms of the fault finding techniques, you mentioned obviously IR there for the thermal imaging cameras, etc. Are there any other techniques for fault finding? And in terms of products, what does Fluke also offer in that area?
Yeah, most solar installations have some form of monitoring platform. We go from residential installations that typically use the monitoring provided by the inverter manufacturer. And when we get into the larger commercial and utility scale projects, they have a dedicated monitoring platform. So that monitoring can give you usually at least a system-wide view of how the system is operating. So that's kind of the first step to see is the system doing what it should be doing. Beyond that, we have a couple different tools that we use. We talked about thermal imaging cameras. That's become the industry standard for diagnosing issues with the array and with the electrical equipment as well. like I said, the modules that are running hotter than other modules are typically an indication that there's an issue there. Once we've identified a location that has an issue, we can go in and use a variety of tools to diagnose different problems. We use insulation resistance testers to find intermittent ground faults, which are a wire that's typically had the insulation rubbed bare or been pinched between pieces of metal, and now it's making contact with the module frame or the racking of the array. We have current clamps where we'll use to detect current, and we can see if current is out of the normal parameters. So we have a solar-specific current clamp at Fluke. It's the 393 meter. It has a 1500 volt rating, which has become a more common voltage on the DC side on utility scale projects. So we have that meter, and it has a high category rating, so it has a high safety rating when we're working with these types of arrays. We have some digital multimeters, which we'll use for testing voltage, and we've got different versions of that. Like I said, the 393 meters rated for 1500 volts, so that's a good option for utility scale projects. Yep. We have some other meters, like we have a 325 clamp meter that's rated for the lower voltage installations. It's a little more cost effective than 393. Yeah, so we've got all kinds of products like that. We've got a couple of different thermal imaging cameras. We have some ground resistance testers as well, which are typically used in commercial and utility scale projects to make sure that that array is connected to the ground properly, which is a safety feature in the array.
Yeah. So, yeah, there's certainly obviously a lot to go there. You've got some specific products, and then you have some of your more generalized products that people are very familiar with, your current clamps and your multimeters, for example.
Yep.
Just before we finish, Will, I'm just going to ask you, in terms of any advice that you would give to anybody who's in this industry or who wants to find out more about it, are there any tips that you would recommend for, thinking about solar panel installation, for example?
Yeah, the Fluke has a dedicated solar site, so solar.fluke.com is a great place to go. We've got some resources there on the equipment that we offer that we recommend to people working in the solar industry. Fluke, we're going to be celebrating our 75th anniversary next year. We've been around for a long time. We really take a safety approach to our tools, so we want to make sure that the people who are using our equipment are going to go home at the end of the day, safe.
Yeah.
When you're working with solar, you've got high voltages on the DC side, which is the solar array side. We're also working typically with high voltages on the AC side, which is the utility side. So there's a lot of hazards there, and having the properly rated equipment to deal with those hazards is really important. So a lot of resources on our website there. Our general website has some great resources on things like meter safety and how to check your equipment before you use it. So those are great places to start.
Great. Yeah, obviously solar is gaining more prominence. Not, as I mentioned at the beginning, domestic use is probably how most people associate with it. But then also, in terms of solar farms, for example, there is a growing need for that. So that's been really great to talk to you today. And yeah, we'll put some of those links to your website below this video if people want to go and have a look and check out Fluke's approach to solar power. So Will, once again, thanks for joining Design Spark, and I hope we can talk again real soon.
Great. It was great being here. Thanks for having us.